y equals negative 6 All right, and what do they want to know from the directions? Read me the directions to it.
The
Transformations, period, and phase shift. All right, so here's this. Transformations are, that's a transformation, and that's a transformation. In what order should you be ready to do them in? Remember, it's a multiple choice test. So I've always told you to start on the inside. But is it okay if the answer that you're looking for starts on the outside? Yes, you can start on the outside or the inside. If you start on the outside, which should you do first? Do you stretch before you flip, or do you flip before you stretch? Stretch before you flip. That makes logical sense, right? Because in gymnastics, you would want to stretch out before you'd flip. All right, so this is the stretch, and this is the flip. So this would be first, this would be second, and then this would be third. Could the answer key start on the inside first? Yes, so option B would be start here first. And then of the other two, which one should be first? Stretch before you flip. So then this should be next, second, and this would be third. So either the red way or the black way are both correct. All right? Next, the period. The period is 2 pi for anything that's signed, except if there's a b term. So it's 2 pi over b. What is the b term here? That is the b term, and so you go 2 pi over 5. So that's what the period of this thing is. And then the phase shift. The phase shift is if there was something in here that's shifting it, like -2 or something, but there's nothing in there. So it's like there's a +0. So is it shifted at all? No. So you just say none. Let's do one where there actually is a phase shift. So would you read me C as in cat? Y equals
7 over 3 times these x plus 5 over 6 minus 1.
Is there a pi in there, or is it just 5 over 2? Okay. So is that a phase shift? Yes. And it is as simple as it looks. That's the phase shift. Done. Okay, but if there had been a number in front of the x, then on that kind, we have to do a special thing for the phase shift. Is there one like that on your sheet somewhere? Yeah, B, as in banana. KV, would you read me B?
y equals 5 cosine parentheses 3x minus pi over 6.
All right, and to get,
Plus,
oh, okay, plus 0.5?
yes.
All right, so then the phase shift is this thing, but you can't just say negative pi over 6. You have to do a phase shift, has to include this front part. Now, we had a discussion about how you could argue that it was negative pi over 6, but I want to remind you, the answers are multiple choice. So you'd want to factor in who made the test, and that person's way of doing phase shift is like you have to do it in this certain order. I think you can do it in 2 different orders, but if we're going to have to do it this way, how do you get the phase shift if you include both those parts? You set the whole thing equal to 0. Everybody underneath it, write this. This is for phase shift. All right, so you set that equal to 0. 3x minus pi over 6 equals 0, and then you just solve it. Solve it for x. Then you'll know the phase shift. That factors in the 3. So then you add pi over 6 to both sides. 3x equals pi over 6. And then you divide by 3 on both sides. Or I'd rather multiply by 1/3 on both sides, because then I can do that easier here. See? And then this will cancel this, and I have x equal to pi over 18. So that's the phase shift for that one. How did we do it again? All we did is take this, set it equal to 0, and solve.
So that's all you wrote is phase shift equals.
Yep. And is it positive? If it's positive, it's going to go right. And if it was negative, no, wait. Make sure that's right. Yeah, positive goes to the left, and negative would go to the right. Okay, so this one's positive, so it's like adding pi over 18. So then that's like going left, pi over 18. Yes?
When you're in the inside parentheses, since everything is opposite, you still need to shift left.
It's a good question. On the inside, you do everything in the opposite of normal. So if you were on the inside, like on this one, and you got this 3 here and you got this, what's normally first? Normally the 3 would be first. So we would do this first, and before the 3. Now what if that 3 had a negative on it? Let's say it was negative 3x plus 7, and it was like sine or whatever. Then what order? Well, normal order is stretch before you flip, which would be this first and this second. This is the normal order, and this would be third. But since we don't want normal order, we want opposite of normal order because it's on the inside. This is first. And of these two, which one would normally be first? Normally the 3 would be first, so it's not. This would be second, and that would be third. Okay, what I'm saying? Just find out the order and you do it in the exact opposite of normal. Okay. Yes?
Should you just go over that equation once in a while?
Sure. So you got y equals 4 sine 3x minus pi plus 7. Okay, there is a general one. This is called the amplitude. Remember how sine goes like this? The amplitude tells us how high it's going up and down compared to the middle line. So this is like the amplitude, is how high up or down it is from the middle line. Okay? It's not the total. A lot of people think amplitude is this all the way down to here. It's not. Amplitude is half of that. Okay? Next thing is, this is your b term. So if you were going to use that, you'd usually use it in the context of the period of this thing is 2 pi normally, but you divide by that. Okay? And that's also a horizontal either stretch or shrink, depending on what number's there. This is a shift, either left or right, depending on whether it's plus or minus. And this is one of those, the whole thing gets shifted up or down based on whether that's positive or negative. And the phase shift, again, the way we're doing it for the test is take that, set it equal to 0, and solve it for x. That'll tell you the phase shift. Okay. Yes?
When it's in the inside and it's like a 3, that means it's a shrink.
Yes.
Is it a shrink of 3 or 1/3?
If as long as you say the word shrink, you could say 3 or 1/3 and you'd be all right. Because the key is, do you know that that 3 makes it get smaller? Then obviously you'd have to use either 1/3 if you were going to multiply by it, or 3 if you were going to divide by it. So as long as you get the word shrink, you'll be fine. Yes?
So phase shift.
Phase shift is one of the transformations. It's just this thing, I'd say it's shifted to the, right pi or whatever. And if they asked me for a phase shift, I would do it differently. Then I would set the whole thing equal to 0 and then tell them the phase shift. Okay, because this is the reason that I'd rather just say it that the phase shift is right pi. Because if you do it in the right order, that would work. But if you did it only if you're forced to do it in a certain order, then you'd have to solve this thing for equal to 0. All right, let's move on. I think I'm starting to lose some of you. Let's go on to number 27. It says graph 2 periods of the function. I'm okay with you guys only graphing 1 period for this packet, because I had to do this section of the key and it sucked because it was just took forever to graph all these things. Yeah, there's like 20 problems, and so we'll just cut them all in half by saying just do 1 period of it instead of 2. And you'll get the idea if you've done 1 period. All right, so just do 1 period of it. Let's do like, again, the first one there, 27a. All right, it wants me to do y equals 0.5 cosine of 3x. All right, so cosine. Do you know what the parent looks like? It's really, really key. If you've kind of forgotten these graphs, you've got to write down all the parents. I'll graph them all for you really quick. Okay, to start with, I'll do cosine for this problem. Cosine is the one that starts at 1, goes down in the valley, and then comes back up again. Okay, so this is your basic cosine graph. From there, you have to know these, that they're 2 pi here and pi in the middle, and then pi over 2 right there, and that spot right there is the hard one. 1 pi over 2, 2 pi over 2, that's 3 pi over 2. It's hard to remember that one for me anyway. All right, so there's your starting numbering. Then do I change it? Yes, because my normal period's 2 pi, but that's going to change that. It wants it to be 2 pi over 3. So if I'm going to divide this one by 3, guess what? I'm going to divide everything by 3. Divide that by 3, and take this and divide by 3, which is the same as multiplying by 1/3, which will make it 3 pi over 6. And this one right here, divide that by 3, which would be the same as multiply by 1/3, which makes it pi over 6. And then when you're all done, you should count them to make sure that they make sense. 1 pi over 6, 2 pi over 6, which would reduce to 1 pi over 3, 3 pi over 6, and 4 pi over 6, which is the same as 2 pi over 3. All right, so there's your numbering. It's based on this. And then this one's got to be renumbering this. That used to be 1. Now it's going to be 0.5. This used to be -1 down here, -0.5. So I've taken that into account and that into account, and now I got my parent one has been redone to be the correct graph. All right, so that was the parent of cosine. Let's do another one where we got a sine. Find the next problem that has sine in it, because we got to get the parent ones figured out. I as in ignoramus. I. Y equals 4 sine of x over 4. Okay. Do you get that that's the exact same thing as if I said 4 sine of 1/4 x? I hope you get that. Because this one will be easier to do because then my b is that. That's my b term. All right, so now for a parent of sine, sine kind of looks like this. It starts at 0 and goes up and down, ends there at 2 pi, and this is pi, and this is pi over 2, and this is 1 pi over 2, 2 pi over 2, 3 pi over 2. Okay, so there's my parent one. Ms. G, would you tell me what to do to change this number based on something in here?
Would be divided by 1/4.
Very good. If you divide by the b, so it's 2 pi divided by b. If I divide by 1/4, would you agree that's the same as multiplying by 4? So it's 2 pi times 4, which would be 8 pi. So if I change this to an 8 pi, I multiplied it by 4, right? So I'm just going to multiply these all by 4. 4 pi over 2. And 4 times 3 is 12 pi over 2. And could I reduce them? Yeah. This would be 2 pi, 4 pi, 6 pi, and 8 pi. There. And then what does this number right here do? Changes the y-axis. Instead of being 1, it's going to be 4 and -4. Okay, I've done cosine, I've done sine. What one rides on top of sine? Let's do one cosecant. Find one. B? All right, we'll go back to B. B. Y equals negative cosecant. That means we'll flip it when we're done with it. 3x. So again, you start by graphing the parent. And to start by graphing the parent cosecant, you got to graph the parent sine. Everybody sketch that. And then cosecant rides on top. That and that, and then it's got dotted lines here and here that kind of contain those loops. All right, that's one period, and again I've said you could do one period instead of 2 periods. All right, so then the parent numbering would be 2 pi, pi, pi over 2, and 3 pi over 2, but I'm going to fix all of them now because I should take 2 pi divided by 3, so I'm going to divide this by 3, divide this by 3, times this by 1/3, which does the same thing, and times this by 1/3, which does that. There we go. And now the negative. Negative of cosecant takes the whole thing and flips it. It's on the front, so it's an up-down kind of a flip. So I'm going to take my cosecant, which are these red loops, and I'm going to flip them. So now it's going to go like that. And this loop down here is going to get flipped up to here, like that. And so technically I could get rid of everything else if I wanted to. I'm just going to get rid of these red ones because it's, I can leave my parent sign in there, but okay, the black ones are really my final answer. That's cosecant flipped and renumbered. All right, I'm willing to answer individual questions on any of these later, but let's just kind of keep charging on so that we can get done and you can have time to work. Go ahead. If you're going to do a, is it a take or a retake? Right here, tomorrow, in this room. I'll pair you up with somebody. Okay, let's flip the page to all the way up to number 28. 28. Because that whole section's about graphing. You really need to know graphing. There's going to be a lot of little graphs on your final. And there are some of the easy points. If you know what you're doing, the graphing ones should be easy. All right, so let's do 28. What's the measure of the larger acute angle in a 3, 4, 5 triangle? Just reading it, you probably have no clue what they're talking about. Why don't you draw yourself a 3, 4, 5 triangle? Kind of, sort of draw it to scale. You know, the longest side is the hypotenuse has got to be 5. Draw yourself a little 3, 4, 5. These are lengths of sides, so they're just like inches. Or
No, I'm talking about the angle measure.
oh, when you're all done, the angle measure could be in either because it doesn't tell you. So I'm going to say this is 5, and then of my triangle, it looks like this side's a little longer. I'll say that's the 4 and that's the 3. And you could have drawn yours any way you wanted. It doesn't really matter. Okay, now which angle is the biggest angle that's not the right angle? So in other words, this is the right angle. Of these two, I got option A or option B. Which one would be a bigger angle, A or B? B, because it's across from the 4. See, it has to be open wider so that they can have a 4 on this side. So there's my angle right there. I'm going to call it theta now. So there's my special angle I want to know about. So how am I supposed to figure that out? Trig. That's what we're in right now, right? So trig, you'd go sine, cosine, or tangent. Actually, any one of them would work. But if we just set up sine of this angle is equal to opposite over hypotenuse, would be 4 over 5. It hasn't figured out the answer yet. What do I do? Inverse. To get an angle, you need inverses. So I'm going to do inverse of both sides. That's what you're really doing here. Inverse sine here and inverse sine over here. And this cancels this. And now inverse sine of 4/5 on a calculator would tell me the answer. And you will have a calculator on your test. So if you've got yours, why don't you grab it right now? Go ahead and work that out. It depends. Does it say in the directions it has to be in radians or in degrees? No. So then therefore you can do either one. What I would leave your calculator in for the test is degrees because you're used to that. If you ever want to do something in radians, just go change it. You know how many degrees that is?
It's a 3, 4, 5.
Yeah, but that's not one of the ones you have memorized for degrees. I think you're thinking of a 30, 60, 90, or but those would be like 1, 2, square root of 3. I'm talking about? So if you have this one memorized, I'll be really impressed. I think you're confusing it with a 30, 60, 90 or a 45, 45, 90. This is not one of those two. What is it, like 53 degrees or something like that? Yeah. Okay. So use the inverse sine thing to figure that out. All right, moving along. Let's go to, 29 is a good one. Remember, every one of these is on the test. There's one like 29 on the test. So if you can't just say, oh, I don't know how to do that kind, well, I guess you can, but then you're saying, I give up on those points right off the bat. You can't do that too many times before you won't pass. All right, number 29. A sinusoid with amplitude 2 has a minimum value of -6. Well, sinusoids go like this, right? And its minimum value of -6 means that this would be at about -6. If I were to make a line along here, it'd be at -6. Okay. And then it says the amplitude is 2. Here's the biggest mistake people make. They think, oh, that means from here to here is 2. No. What is it from there to there then? 4. Because the amplitude is like from here to here is 2, and then the rest of it the other way is another 2. Okay, so it's a total of 4 from there to there. So if this was at -6 and you go up 4 from there, where are you at? -2. So that is called the what? the maximum would be at -2. Okay? So if I knew I was at the low points were here were -6, and I know the amplitude, you've basically told me how far to go up to get to the highest point. I needed to go up 4, so we got to -2. All right, there's another one just like that you can do at home for your math pleasure. Moving on, number 31. Find the domain and range of each function. I like to look at pictures for domain and range. So why don't you sketch with me, number 31. 31A. And if I'm going to make the log and then move it down 6, that's what the -6 means. Y equals ln x minus 6. I got to know what ln x looks like. I have these memorized. If you don't, you better make the little list for yourself to memorize, like off to the side. Here's log. That's log. Okay, so that's log. Here's another one you need to know. What's that one? Exponential. Y equals e to the x. This one was log. Y equals ln x, or log base anything of x. Kind of looks like that. Log base 2, log base 3. Just remember, log base e is actually ln is log base e, and e is about 2.7. So this would be the same as if I said log base 2.7 of x. All right, anyway, there's a couple parent ones you need to know. How about x? Yeah, that's probably good enough for now. Okay, so then what is my domain and range on this puppy? Well, if I know this is kind of how it looks to start with, and then I shift it down 6, it'll go down, but notice it's not going to like be way down here. It goes down 6 and such that it's going to still cross. There's no limit to these things. Log keeps going up, 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 so it's eventually going to go toward infinity, so to speak. So yeah, I move it down, but it's still going to go to infinity. Don't think of this as a like one of those kind that has a limit on the top. Logs do not have a limit on the top. Okay, so what is the answer? Domain goes this way. That's domain. Ranges go this way. All right, so what's my domain? My domain is from the smallest it'll ever be. No, sorry. Farthest this way. What's the farthest this way that my blue graph will ever be? 0. To what's the biggest it'll be when I go that direction forever? Infinity. Parentheses around both of them because it never gets to the 0 and it never gets to the infinity. The range on this thing, what's the lowest it'll ever go? Look at it, it's going down forever. Negative infinity. Never actually get there though, so I put a parentheses. Comma, what's the highest it'll ever go? So you need to know those for your test. You need to know domain and range, that concept. Domain is left, right. Range is up, down. Okay? So once you've got a little picture of these things, it'll be a lot easier for you to know kind of, what the domain and range are, like where they go. All right, number 32 is called, what is that called again? That's called a logistic. Do you remember those? Y equals 12 over, they said f of x, I said y, it's pretty much the same thing. 1 plus 2 times 0.08 to the x. All right, this is just 0.8, sorry. 0.8 to the x. All right, now, the first question is, what's the y-intercept? If you can answer this question, you'll know that answer. The y-intercept is where what? X equals 0. You need to know that. Repeat that. Y-intercept is where what? X equals 0. And the x-intercept is where what? Y equals 0, okay? So remember that. So when they ask for the y-intercept, it's easy peasy. If you know, it's where x equals 0. Put a 0 right there, figure it out. You go, okay, 0.8 to the 0. You got a calculator, but that's 1. 1 times 2 is 2. And then 2 plus 1 is 3. And that's 12 divided by all of that. 12 divided by 3 would be what? 4. So the y-intercept is really easy. If you know, you just stick in x is 0. The y-intercept is where x is 0. Okay, and the next part is the horizontal asymptotes. Do you remember that this kind of graph looks like this? Another parent one of the 12 functions you're supposed to know from precalc. This is the logistic function. It has an asymptote here at x equals 0, and it has another asymptote here wherever it happens to be for that function. This one's 12. That means it's 12 here is the highest it ever goes. So does it have asymptotes? Yes. What are the asymptotes? X equals 0 and x equals 12. And did I just do that wrong with x equals? Yes, I did. Those are y equals things. Sorry. The horizontal asymptotes are the horizontal asymptotes. They have a y. Y equals 0 and y equals 12 are the two asymptotes. Do you remember those? These are used for populations. So if your population, like habitat for your rabbits, can hold like 22 rabbits, then you'd have a 22 there. That's the highest population it'll ever be. Use those for modeling. All right, we have done a lot of stuff this semester. I understand that this is a lot to try to remember, but I'm trying to get you ready for everything so that the seniors will be ready for Friday. So covering a lot of stuff. Let's do number 34A. 34A has an apple. Get there now, please. 34A says cosine of theta is 5/11. And it wants all the other ones. Well, first thing I'm going to do is list all my functions that I need to find. There's 6 of them. They gave me one of them. Sine. Squeeze it in right above it. Cosine, tangent. And then what are the other 3? They kind of go with them. Sine goes to cosecant. Cosine goes with secant. And tangent goes with cotangent. Now, I've got 2 of my sides, so I can do which one? Super easy. Secant. And that would be what? 11/5. But that's the only one I can do like right away. The other ones, I need another side. I've only got 2 sides. So you set up your little triangle, and I'll tell you, it kind of looks like this. Cosine of this angle would be 5 ka, adjacent over hypotenuse, over 11. And then I have to figure out this one. It's always a square root of something. Sometimes the square root happens to work out, but... And this would be 121 if you square this. Take away the 25 for that. 121, take away the 25. This is 96, and then so it's a square root of 96. Do you actually have to figure that out with some decimal? Nope. You just leave square root of 96 in all your answers. Now that I've got that drawn, all the other functions are super easy. What is the sine? Sine is opposite of hypotenuse. So I put opposite on top and hypotenuse on the bottom. What's the opposite? Opposite square root of 96. Hypotenuse is 11. We're at 96 over 11. And then the cosecant, you just flip it. Put it over here. Tangent, opposite over adjacent. I think from there again. If you've copied down this triangle, it's going to be super simple now. Yes, sir? If you can reduce the square root, you should, but remember, multiple choice test. So they're either going to say square root of 96, or if they have something that's reduced that looks like it could be reduced from that, it'd be fine. Is there a simple reduction, like, does 49 go into that? I don't think so. Anyway, let's move on. Flip the page. Let's do C on the top of the next page. It seems so simple. And it is fairly simple. But do you remember how to do it? Cosine of 120. Start by making your little circle. I strongly encourage you every single time you do it that you go like this. All students take calc, because the mistakes that you're going to make on this are probably have to do with where things are negative in those other quadrants, you know. So where is cosine of 120? Well, I got to find where 120 is. 120 is like over here-ish. Right? And so we use this reference triangle that's over here. Remember that? And the central angle in it right here is going to be, well, if it's 120 and the total is going to be 180, that'd be a 60, right? And so then you go, cosine is adjacent over hypotenuse, so I'll need to know these sides. And I happen to know the sides in a 30, 60, 90. And they are 1, 2, and the square root of 3. And one of them is negative, and if you forgot that, the whole thing is going to be really awful. Because they guarantee you that they'll have that as one of your distractor answers. All right, so I have remembered that that's negative, so I'm going to be all right. Cosine is adjacent over hypotenuse. Adjacent is -1. Hypotenuse is 2. Answer is -1/2. Notice they gave me an angle, and they wanted me to figure out the sides. Any questions on that one? Okay, let's move on. We got to get to the end of the up to 42 for today. So I think I'm gonna next skip to number 39. Let's do some inverse trig. On 39, we have inverse sine of root 3 over 2. Did they give me sides or did they give me an angle? They gave me the sides, so what do they want me to figure out? An angle. So I need to draw a little picture that has sides like they've given to me. Doing it in this context would make sense, so this is all students take calc. And is it positive? Yeah. So sine is positive here and also over here. But do you remember that inverse sine is only allowed from here to here? So therefore I'm not going to use that. In case you've forgotten that little deal, you might want to make yourself a little reminder chart. Inverse sine's only from there to there. Inverse tangent's also in the same spot. Only allowed from there to there. And do you remember where the cosine is? Top, yep. Cosine's only allowed from there to there. Okay, so now back to my problem. So since I have a positive one here, and it's inverse sine, and the inverse sine is only allowed from here to here, I'm going to draw it right here. And its sine is opposite over hypotenuse. Opposite is square root of 3. Hypotenuse is 2. There we go. And this must be a 1. And so is my angle the 30 or the 60? It's the 60. How come I don't go over here, you say? Because inverse sine isn't allowed over there. So, okay. So much to know. Moving back to the problems that are right above number 40. So they're still from 39, but go to the next page. Let's do G as in gangster. Cosine, parentheses, inverse sine of 1/2. You know what? I don't like this one. I want to do something else. I want to do H. Forget. So you can do this on your own. I think you can handle it. Start on the inside, work your way out, just like the Alien. H. There is the new Alien movie coming out. And it's going to be the prequel to the first Alien movie. I was hearing somebody talk about it, like a reviewer kind of person, and saying they thought it was going to be really good. So, we'll see. All right, so do you know how these inverse sines, it seems like they could just cancel? Do you remember having fits with, like, sometimes it'll cancel, sometimes it won't? Okay. I would encourage you to never just go like this and say that the answer is 3 pi over 2. Because sometimes it'll work and sometimes it won't. And a method that only works for you some of the time is useless. Know what I mean? So if you've got 3 problems on the test like this, it's very likely that one of the 3, either one of the 3 it'll be okay to cancel, or one of the 3 it won't be okay to cancel. I mean, don't just trust that it's okay to cancel. So if not, then what do? Well, you start on the inside and work your way out. This, they gave me the angle and they want sides. So I go back quick and figure out what that is. Sine of 3 pi over 2. 3 pi over 2, where the heck is that? Well, pi over 2 is here. 2 pi over 2 would be here. 3 pi over 2 would be down there. And sine of that, I can't even make a triangle for that, so then I go -1 comma, no wait, 0 comma -1, right? And what's the sine there? The sine is the y, and that's the y, so it's -1. So that whole thing right there is -1. And now it's asking me for inverse sine of that. Is that allowed, first of all? Is it in the zone where it's okay? It goes from here to here. Does it include that or not? Yes, it does. Okay, so therefore it's allowed. I can do the inverse sine of that. Inverse sine of that, I got to now figure out, it's given me sides, and now I need an angle. Well, what angle am I at if I'm right there? It's 270 or 3 pi over 2. So would it have canceled this time? Yes. Would it be a lot nicer if I'd have known that ahead of time? Yes. Can I guarantee you they'll always cancel? No. A lot of times they're like not allowed, and therefore it won't just cancel. It'll be like no answer. So don't just trust that they will cancel. Sometimes they do. And the last one I want to do with you is numero 40. Although, is that even on the test? It must be on the test. Yeah, we better talk about one of those. Okay, number 40, part A. It's got sine of inverse tangent of x. Do you remember that that's also called arctan? That's on the test too. If they said arctan, you got to know that that means tan to the negative 1 like that of x. All right. Now, why is this different than all the other problems? Because all the other problems, they told you a number to stick there, like 3 pi over 2 or 1/2 or something, but now they just have an x. So let me ask you, in this kind of a problem where you're doing, starting on the inside, and you're doing the inverse tan, have they given you sides or have they given you an angle? Think about it. Sides. They're giving you sides. Because whenever you're doing an inverse like this, you're trying to figure out an angle. All right, so they gave me sides. How do I draw something where tangent is x over 1? Tangent, I just draw a little triangle. Tangent is x over 1. Think about it. Where should I put the x? The opposite side. Over tangent's opposite over adjacent. The adjacent side is here. X over 1. Sketch this triangle. You'll have no way to do number 40 without that little triangle. And the last part uses hardcore. Hey, you're in pre-calc now. Should be able to handle this. What is that other side as a big square root? Square root of 1 squared plus x squared. And what's 1 squared is 1. Yeah, see? Because this is just Pythagorean theorem. This squared plus this squared will go underneath there. All right, so now I got my sides. And now what do they want to know? They want to know the sine of that. See? Sine of that same angle. What's the sine of that? Sine is opposite of hypotenuse. X over, what's the hypotenuse? Square root of 1 plus x squared. And in the old days, we would have made you rationalize that denominator, but not anymore. So you can just leave it like that. All right, that was a tough one, I know. So keep yourself motivated. If you stay on track, you should get through 42 today. And I've done a lot of them for you, you have to admit. I think some teachers are just giving work time during this time, which is a different way to do it. And you would have got some done doing that too, but you got a lot of free ones from me. Now go fill in the rest. If you have trouble, get stuck, come in and get help in the morning, or just for the next 15 minutes or so that you have left, or 10 minutes or so that you have left, you can work. Stay caught up if you do. I did find out, though, I cannot give you the test on Friday. I'm sorry. The principal, I asked the principal for special permission to do it because it seemed totally logical to me, but only seniors can take it on Friday. That's, I think part of it is, I'm not exactly positive why, but I think part of it is they want seniors to have something special to be able to be out of here a little bit earlier. And if everybody gets it, then it's not special for seniors. The other thing is that basically they don't want too many kids with lots of free time at the end of the year, because kids with too much free time tend to cause trouble. So I think that's what the principal's perspective is, and basically they're my boss. They said, no, you can't do that. So I'm saying, okay. So you'll just have to take the final on the normal day unless you're a senior. But we are done on Thursday with reviewing, so whatever time we do have together, it'll be a time where you can work and you can ask me questions. You'll have 2 hours where you can ask me one-on-one questions. So if you get stuck on a packet like this one, and this one, you can get questions on that day. All right? Okay, rest of the time is your time.